Just in time, as expected from the German International Conference, I guess. So we will start at 45 sharp. Our talk today is about integration testing of Keycloak Terraform modules. I'm happy to see so many faces. Yeah, and let's dive into it right away. So this is our agenda. You can see we have basically split the talk into 4 parts. One part is just a small introduction. Then we go into the use cases where we will show you how we basically use Keycloak in our company. Then we will show you the concepts we have applied for our tests. And in the last part, we will have some demo, which will basically take half of the talk. So yeah, my name is Fabian. I'm a site reliability engineer working at FinMid already for almost 4 years now. And there's my colleague Bart.
Yes, my name is Bart. I'm head of engineering at FinMid. Also joined almost 4 years ago, responsible for engineering department and in my spare time contributing to the infrastructure team.
And now you may ask, what the heck is FinMid? So FinMid is a startup. It has been founded in 2021 in Berlin in the early months of that year. And we are a financial infrastructure provider. And our goal is to be the choice for the platforms as a financial infrastructure provider. So coming to the problem statement of today's talk, so in our company, for us it is very important to have a confidence about the Terraform modules we have, which are also used by our engineers. So we need to make sure that the modules we have are well tested and work as expected. And if we look at the stakeholders of Keycloak in our company, we can see we have basically 2 different teams. One is the infrastructure team, and the other stakeholder is the engineering team. The infrastructure team basically uses Terraform modules to provision foundational aspects of Keycloak, while the engineering team basically uses Terraform modules we provide for setting up clients. Yeah, you can see if we are looking at the first use case that we are basically using Terraform modules we have written ourselves to configure the realms, set up identity providers, configuration of authentication flows, and of course, additional realm level components. In contrast, the engineering team, they basically use Terraform modules as abstraction of Keycloak. So instead of using Keycloak directly in the admin API, admin UI, they can use Terraform modules to set up things. And for our engineers, basically 2 kinds of clients are important. One client is for authenticating users, and the other client is authenticating services. So those services can then use the Keycloak admin API. So looking at 2 different roles in our company and the expectations these roles might have. So if we are looking at I think from your perspective, it's the left side, we are looking at the developer. And the developer's expectation is basically that they want to set up Keycloak resources on a self-service basis in a reliable and safe way. And most important thing is they are not blocked by the infrastructure team. If you look to the right side, there's the motivated SRE, and this guy, he also wants to focus more on improvements and support in important matters and not wasting time in setting up common stuff for the teams, right? So let's see how we can basically align these 2 expectations. And this is our approach. So what you can see here is the most important aspects. So you can see we see Terraform modules as products that basically allow engineers to interact with our infrastructure in a safe and predictable way. And basically interacting with infrastructure becomes a self-service for common tasks, like setting up a client, for example. And engineers are mostly unblocked. And to make this happen, of course, thorough testing, which covers all the relevant configurations, is important. And we need to ensure that the modules we have provision the expected state of resources. So let's have a look at how we do the testing at FinMid. So first of all, I want to explain you how we built the Keycloak image. So our local tests in our local environments and also the Keycloak that is deployed to production in our company, it basically is the same image. And you can see we have two stages here. So we have a Keycloak builder image, which we use to assemble config, plugins, themes, and some other stuff. And the build results of this, we just copy to the production image. And you can see we just take the official Keycloak production image and simply use this image then for local testing and for tests and deployment in the CI, of course. So let's talk about two important testing types or strategies we have in use. So one is integration tests. So here the idea is that we spin up a production-like setup locally and of course in the CI, and we apply the same infrastructure modules we use for production also in our testing infrastructure. And of course, we verify then the expectations we have from these modules against the Keycloak admin API. So let's say we expect a certain client is set up or a certain description is there. We can verify this by checking against the Keycloak admin API. So the next one is browser tests. We just called it like this, but in the end it's Playwright. So you can see it here. It's powered by Playwright. We use it to spawn up a real web browser. And this is for us to avoid regression and that we do not break existing flows by doing module changes. And especially useful for login flows, of course. So all the authentication flows are basically tested by this. So let's talk about a few things. Oh, it's there. Let's talk about a few things we are using in our testing. So we are using GUnit 5. I know there are multiple ways to test Terraform, but for us, because it's with Keycloak, it's the best fit. So we use multiple extensions of this testing framework to set up the environment I was talking about. Then, of course, we use test containers. So Keycloak itself is kind of a testing container. We have Postgres, which we set up as a test container plus mock server to basically mock the production-like environment. As I just said, there is Postgres. You see it over there. We set it up as well. And the important part about Postgres, maybe I forgot this. So we have a lot of extensions we use in Postgres, and we set up the test container of Postgres also with the same extensions. So we make sure that this is also not breaking stuff. APIs of external services and third parties, we mock using mock server. I think this is a pretty common thing nowadays. And we can test scenarios like slow or error responses. Then one of the most important building blocks, of course, Terraform. So by using the provider from Michael Parker, now adopted by Keycloak, of course, we were able to basically configure all of our Keycloak using code in Terraform in a very well-documented, self-documented and descriptive way. And then we have TerraGrunt, which is just an wrapper around Terraform. You might have heard about it or use it even. It helps us to avoid certain pitfalls from Terraform itself. And also manage the dependencies better between the Terraform modules. So let me just quickly show you how a typical flow might look like. I hope this can be seen from the very back, but in the end we have a developer. This developer commits and pushes changes. By the way, until here, everything looks the same locally. I just put this here like the full picture. Locally, it would be the same, right? You do changes, you apply our testing infrastructure by executing the testing infrastructure stack, and then you do your test locally. And in the CI, this exactly same thing happens, of course. But in the CI, it goes further, of course. So we have the testing in the CI, and then after the testing, we apply a different production stack to the production environment, of course. So important here is to acknowledge that we have a test infrastructure stack and a production infrastructure stack. So let's get to the use cases we have for today's demo. One use case is authenticating apps. Basically using the service account client feature, so OIDC service account client of Keycloak to authenticate applications. And the second use case, of course, authenticating users. So basically using the standard flow client to enable regular user logins. And now it's demo time.
Okay. So let's hope the demo gods are with us today. So I think that was, would like to walk you through a little bit of the code base to show you how things are looking on our end. So I will try to enable presentation mode. I hope it's big enough for you to see. So we'll walk you through the setup that we have, and then hopefully it will give you some insights how do we run all of this test. So as mentioned, we have a two-step process to build a Keycloak production a Docker container. So this one is just basically, we have a bunch of extensions that we compile. We use Kotlin, by the way, but just compiled into Java. All of them are compiled in advance. We use standard, way of, using the micro build image where we just install a couple of dependencies. Then we, of course, extend official Keycloak image. We copy our extensions. We copy our custom themes. We copy some configuration files. We run, a couple of dependencies, and then we run, a build command that basically builds the Keycloak image, that can be used as a base. The second thing is the image which we run. So we basically also extend the same version of image. We copy the artifacts from the builder image, and we start the image with optimized flag. So we want to make sure that the Keycloak is pre-built, pre-optimized, so there's no way also to hijack any entry point and do something else in the meantime. So it's the same reproducible image that we could use for testing. Now let me show you a little bit of the structure. So we have our repository. We have a bunch of Terraform modules which represent different things. I can walk you through maybe, don't gonna go too much to details, but we have a couple of realms. We need to provision them. We have a master realm. For sake of this presentation, we can use a platform realm. So the realms are singleton modules. They are very unique, specific, but we have two types of clients. One is the service account client. This client is used for backend applications to interact with our Keycloak API. We have this example where one of the service would like to query a list of the users and do something with that. In order to do that, they need to authenticate against Keycloak API. This client is basically responsible for that. And standard flow client for us is the client for the browsers. So in the end user is authenticating with Keycloak. This particular client is being provisioned. Then for our testing, maybe for our live and staging environment, we have our Terragrant modules. In that case, for example, we have our platform realm. This is basically provisioning the module which was described before with a couple of inputs. It's important to say that we need to authenticate also from Terraform side to talk to Keycloak, right? So we need to have two providers. One, we need to be able to authenticate against Keycloak to provision another realm, yeah? But once we have a realm, we are also creating dedicated user to interact with this realm. So if the client would like to, create a Keycloak client on their own, they have to use dedicated username, like client ID and secret to interact with that. So this is our staging and live setup, which is basically identical. It's using the same modules, just with different configuration. And for the testing purpose, we have our Keycloak test module. Over here, we have our Terraform setup directory where we basically provision same modules just for the test environment. So a couple of basic things. We have a Terragrant common file because we would like to keep our Terraform states not in S3 bucket, but locally in .states directory, because this is just for testing. We have our provider for admin. Of course, for admin, we use admin. It's only local testing, so that's completely fine. And we also test that we provision dedicated client ID and secret for the provider that will interact with the given realm, and some random provider just to generate random passwords and so on and so forth. Then we have our realms. This is the module that provisioned a bunch of realms and configuration for these realms. And then over here we have a bunch of we can basically create different Terragrant modules using our Terraform modules that have been created before. Maybe let's start with this one. This is our service account client, which let me do it again. This is our service account client, which basically, because we use Terragrant, we can have dependency. So we provision realms module first. This module outputs client ID and client secret for the platform Terraform module. And in that case, we can provision, for example, in that case, we have a client ID called distributor master data service, which has certain roles. In that case, it only has allowed to view users and manage users. Yeah. Then the second one, which is worth exploring for today, will be back office. Back office, from the other hand, is using standard flow client, so client for the browsers. It's quite similar. It also needs some client ID and client secret to be able to talk to Keycloak from Terraform perspective. And in that case, we can also, for example, in that case, we on the SRE side provision browser flow, like authentication flows, but the client has to attach certain authentication flow to the client, right? And then we can define client roles, group assignments, redirect URIs, and so on and so forth. So this is for the testing purposes. And then we basically can create as many clients as we want in different configurations. And this particular Terraform and like Terragrant modules are applied against local version of Keycloak, right? So the two Docker steps that I show you, they are building the image. And this image we run locally, and then we apply Terragrant against that local instance to make sure it's always in the same state. So let's open some example tests. So just to show you a couple of things, how could that look like? So for example, we have, maybe I will show you a couple of extensions, maybe that will be helpful. So let's open with something called combine extension. As Fabian mentioned, we need to connect a couple of things together. So, we have to have a network. So all of containers have to be able to talk to each other. So we create one network so they can speak to each other. We have our Postgres extension. It's basically JUnit 5 extension, which runs our test container for the Postgres. In that case, we need to configure a couple of things. I don't know, some extensions, username and password. All of this happens here programmatically. Then on top, we have a Keycloak extension. This extension is basically a wrapper, like JUnit wrapper on top of Keycloak IT local. This is the local image, which is built locally. And here we can also configure a bunch of parameters for Keycloak, like, authentication URLs, the health check, Quarkus, we use Sentry, so we also disable this for the test. We can also pass certain parameters that we want to do. Locally, we use HTTP, we don't use HTTPS, and a couple of environment variables that helps us to run the test container of Keycloak that we just built. So this is like a wrapper on top, this is like a test container wrapper on top of the Docker image that we built in the first place. And then we have mock server, same thing. Why we do that? Because on our end, we have another API which is responsible for sending SMS. So we have extension that calls that API and sends SMS. So for the testing, we need to mock it, because our goal is that we want to run this test locally offline. So we don't want to deploy Keycloak to staging environment and run tests against this. We want to be able to run it locally without online access at all. So mock server is just the same stuff. It's a test container which runs the mock server, and it can also, let's say, mock some APIs, and it also allows us to emulate different situations. We can emulate 500, slow responses, whatever. Any reproducible scenario you can potentially happen in production, it's reproducible locally. And then, of course, we have a Terraform, where we basically fetch the Keycloak URL of the local container. We fetch mock server URL of which just run because it's random port, and we pass them to our Terraform local apply. So if you open local apply, it just literally runs TerraGrant apply, and we just pass to environment variables because we need them in our modules to know against which instance of Keycloak we need to apply our stuff. Yeah. So we can maybe run all of the tests in the meantime to show you. So it's nice, you can just run it from IntelliJ. We have a lot of different tests from multiple things. So we can just literally run it, and then we can see what's going to happen. So in the end, we expect to have pre-built plugins, and we expect to have pre-built Docker image. In our CI/CD, of course, we always build plugins from scratch. We built container from scratch. For sake of this demo, plugins I compiled earlier, and also I built local image, so we are not wasting time. And what's going to happen here is that we will spawn all of test containers. So all of these extensions, they have dependency among each other. And then you can see all of tests are being executed at the moment against local instance. And it really doesn't take too long, even if you take into account spawning all of the local containers, right? So now we run the test. So if you think about it, test took 16 seconds. Maybe with running containers, 30 seconds, which is quite a good result. If you take a look on the output, you will see that, we basically apply, there's quite a lot of stuff, but yeah, we run, of course, the Postgres container. It also prints, like all of the SQL statements that are being executed. It runs mock server, and then it also shows you nice, Terraform plan and apply output. So you can see exactly in the same way as you would run it at least on our side on production, right? You can basically take a look on all of the things that will happen, what have been applied, and all of this is applied in one go, and it really doesn't take too much time. The second test, so maybe I can also show you the authentication flow test. Let me do this. So in that case, we have certain authentication flow, and we expect certain steps to happen. In our authentication flow, because we have custom extension that sends SMS, we have a user session limit config, and so on and so forth. So in that case, we have abstract test that spawns everything, and then we just execute expectations that we want to make sure that our flow looks like this. So this is basically using a Keycloak admin API to fetch authentication flows and make sure they have proper order by checking the level and index, and then we make sure that it works as anticipated, and we can also make sure that this is how we will mock the API call to send SMS. The second type of test is UI test. So here we have our Playwright extension, which basically allows us to run web browser tests. We have our custom themes. We have custom authentication flows with extensions. Of course, these extensions have their own unit test, but we would like to make sure that we have an end-to-end test that checks everything in the local test environment. So in that case, this is running the browser. For sake of the demo, I think we'll show you how it looks like in the browser. So what I've changed, I just added, I changed headless to false, so it will open the browser. And it also at delay seconds, so you will see how it looks like. I think I'm going to escape full screen, so you will see how it looks like. So let me run this one test to show you how it looks like. So if you want to debug, let's say front-end engineers would like to add something to custom theme, and they want to make sure that nothing has been broken because of that. In that case, they can just check out Keycloak, run it locally, and then debug or run the test to make sure that whatever they have done didn't break anything on their end. Yeah. So in that case, it's fully reproducible example. It also helps us to make sure there are no regression issues, right? Because in that case, you can see it opens the browser, user, password, login, TOTP. We have this remember me. Yeah, we take it off. So we want to make sure that if you log in again, you'll be asked for TOTP. Yeah, this is one of the examples. If you tick that checkbox, in that case, it will ask you for TOTP again, right? Very simple, remember me type of test. Of course, if you run them like this, they take 20 seconds because you can see the browser, but you only change it when you would like to debug as the engineer. But let's say we add some mistake. We change the password and we run the test again. We're also gonna run it with the browser, so we can take a look on that. In that case, it also allows you to automate fully user expectations from the browser side. Playwright is a very nice framework. I really recommended this. We've been trying different types of framework in the past, but I have to admit Playwright is the best from the resource point of view. And also, it's very modern comparing to other frameworks. And I have to admit that you can also run different types of browsers. In that case, we type the password. You can see email password is wrong. And then I think there's a 30 seconds timeout by default. So the test will time out because expectation is wrong. But of course, you can also add a test that makes sure, let's say, today we had a lot of discussions about translations. We also run different translations. It also allows us to write automated UI tests that test our translations because our custom extensions also need to have translations. In that case, we can also validate that error messages are correct. And then if you change something somewhere, you'll be able to find if the problem pops up or not. And just looking at the time, maybe let's talk about one example where we would like to change something. So basically, this is more or less about the TDD distributor. I forgot the name of the test. I think it's client test, right?
Yeah.
Yeah. So imagine that we have I can do demo. We have a distributor master data service client, and we would like to add view clients permission, right? So we want to extend it. We want to allow our backend service to view clients. We have our integration test. We add TDD. We add I would like to view clients, and let's run the test. So in that case, we want to make sure that there'll be another privilege of that particular service to be able to view the clients, not only view users. In that case, test will fail because, this is not what we have as of now. Let's wait a couple of seconds to spawn the stuff. In that case, it will really help you to write your expectations first. What do you expect from the test? Right side, yeah, we can see that, and then it failed, and it failed because we have users manage view clients in any order, but we have only these two, right? And it even tells you you're missing view clients. In that case, we can open our the module that we have seen before. So let's quickly jump to Terraform setup, Keycloak test our distributor master data service client, and we can add view clients here. Yeah. So we add view client and we run it again. So in that case, we make sure that whatever test described, it works as anticipated. And on top of that, we make sure that we didn't break anything else, any other test, right? So this really allows us also to have a clear contract between infrastructure team and engineering team, because the Terraform module is our contract. This type of test really allows us to set up expectations, also give freedom to users to do stuff they need on their end, but also have enough control on our side to make sure it works as anticipated. You can see the test is green. So yeah, we are sure that we can now add this permission to that particular client, and then nothing else broke in the meantime. So just to sum it up, this entire setup helped us to run things with like way more confidence we have had in the past. First of all, we have very clear interface between one team and the other. So, in our organization, engineers are responsible to provision infrastructure they need to run the software. Keycloak is provisioned by us, the server side, but the clients are provisioned by the engineers. In that case, we found very good way to decouple one thing from the other. We have now very good regression testing capabilities. We have, different testing strategies for the UI test, for integration tests, which are really low cost if you think about the maintenance. Everything is configurable in the code. There's no ops, click ops in the admin UI. It's very easy and reproducible. You have, pull requests for Terraform module. You have pull requests for test change and so on. You can audit who have done what and when. You can review the changes. And if something goes wrong, it's very easy to roll back because you just deploy previous version. Terraform will do the job. And in that case, you can go back to the previous step without much hassle. And the most important one for us, our upgrades is way more predictable today. When we run our integration test, we bump new version of Keycloak, we upgrade all of dependencies, and then we run our integration tests. So far, since we introduced that change, we are able to catch all of the problems before we deploy to production, which helps us to confidently upgrade Keycloak without running issues in production. Of course, if you would find something, we'll go back, write a test to make sure it doesn't happen again. But in the nutshell, it helps us to upgrade Keycloak with confidence that it will work as planned. I think that's it from our side, from the demo. The gods were with us today. So we are happy to answer any questions from the audience. Thank you.
Quick question. What's your experience with adopting Terraform for an existing Keycloak deployment with existing realm and client configuration?
We did this. We did exactly this. So we also went the hard way of doing ClickOps in admin UI before, and then somewhat like the mid of last year we started terraforming it, and then I can just say that in the end you can just import the stuff, right? So you just import it to your state, and at least in our experience, it was working very well with the provider. So I can really say kudos to that guy who wrote that provider. It's a really well thing. So it works pretty well as expected. So it was actually easy to integrate this.
Can you find the source code you showed somewhere on GitHub?
The question was, maybe we can repeat, if the code is in the GitHub. Not yet, but we would like to open source part of the code that we have, especially extensions and so on, because they can be very handy. So we would like to, maybe not open source entire repo of our Keycloak, not yet, but we would like to decouple the testing framework to certain repository. So check out GitHub Finmit in some weeks, and we'll try to push it to the open source so that you can also leverage that and integrate into your end-to-end test, hopefully. Yeah?
if there are no more questions, I guess you got some time back. And one more.
A question: when you use Terraform so intensively, what components of Keycloak did you find difficult to configure with Terraform?
I would say in the past, authentication flows for sure. Yeah. We had some nasty workarounds. I think we still have these workarounds, but since they added priority now,
I think the problem is about dependencies sometimes, because authentication flows are very complex and you have to provision them in certain order. And then Terraform sometimes is not super smart about it. So you have to add artificial dependencies. Or for example, if you change one block in your authentication flow, you need to recreate the entire flow from scratch. But Terraform will try to replace that one block, which is not possible. So in that case, you need to revamp everything and destroy authentication flow and recreate it again. So you have to add some little bit of magic to tell Terraform, destroy entire flow and recreate it from scratch because I changed one thing in my flow. But this is like the nature of Terraform and also how the provider implement this. I think it also depends how the API looks like on the Keycloak side. So sometimes you need to be creative and find some way to do that. But to be honest, we managed to bypass all of these blockers. And so far, we also started extending this with more and more features. And it works very well. I have to admit, that's why I asked this question earlier in the maintenance, maintainer talk. How do you make sure that Terraform is up to date? Because there might be the risk that you want to upgrade to Keycloak 26.2 and Terraform provider doesn't support it yet. Yeah, that's why I'm very happy that Keycloak team decided to adopt Terraform, because then we hopefully can see that if there's new version of Keycloak, we are not blocked to upgrade because lack of Terraform support. Yeah, but in the end, we've been thinking about different approaches. We decided to go with Terraform. And I think you ran the survey, what people are using. I was very happy that community said Terraform because we made the right bet a while ago. And we can continue our journey without moving to different mechanisms. No?
One more question.
You maybe have some experience with the fork of Terraform, like OpenTofu or other things in your journey?
Yeah, good question. So the question was if we have experience with the OpenTofu fork of Terraform. To be honest, not yet. We have this somewhere on our planning, but because of lack of resources and time, we didn't cover this yet. But for sure, this is something we will touch also in the upcoming months. I guess we will have to. I assume.
I can add to that. So I regularly try out OpenTofu with the Terraform provider, and up until now I had no issues with that so far. So far it seems to work. Yeah?
Fingers crossed that it will continue working in the upcoming future. Awesome. If no more questions, if you have anything, feel free to approach us. Thank you very much for your time today, and have a great rest of the day.